In the following video, I will show you how to answer the June 2010 question 9, and again it's another question on the calculus of trigonometric functions. Let's take a look straight away. The question asks us to evaluate the following integral. Okay, seems easy, looks quite straightforward, but it's 9 marks. It's going to be quite involved. Let's call this integral that we're going to evaluate I. The first obvious thing to do is expand the brackets here. So I is also equal to the integral of this bracket expanded. So that would be x squared plus 2x cos 2x plus cos of 2x all squared, but the way a mathematician writes that is cos squared of 2x. And all of that integrated with respect to x. Now, we can evaluate this integral by evaluating the integral of each of the 3 components in the sum inside the integrand. We can integrate this easily. However, this here, you may look at that, this here is going to be an integration by parts. So this is going to be an integration by parts because it's a product of 2 functions multiplied by each other. And this one here, we can't integrate cos squared 2x straight away. We have to use what's called the double angle formula. So we're going to need the double angle formula to do that. So there are 3 components to this integral. I would suggest integrating each separately to gain easy marks early on in this question. So first of all, I'm going to work out what the integral of x squared with respect to x is, and that's simply integrating a polynomial, add 1 to the power and divide. That would be a third x cubed plus a constant, which I'm going to call c1. So I'm going to do a line underneath that. There's the first set of easy marks gained. Now what I'm going to go for, the integral of 2x cos 2x with respect to x. Now, as I said before, we're going to use the product rule here. What we're going to do, we're going to divide these into a product. I'm going to call this u because it's easy to differentiate, and I'm going to call this v dashed as it's easy to integrate. If you remember, integration by parts says that the integral of uv dashed is simply uv minus the integral of u dashed v. So I'm going to use this formula here to work out the integral. Now u I've defined as 2x, so u dashed is simply going to be 2, and v I'm going to define as cos 2x. Sorry, v dashed I'm going to define as cos 2x, so the integral of that, i.e. v, is simply a half sine 2x. Plugging these numbers into the formula here, I'm going to get the following integral. So uv I'm going to write as 2x times a half sine 2x, which just simply becomes x sine 2x. Subtract the integral of u dash v, well 2 times this is just going to give me sine 2x, so it's the integral of sine 2x with respect to x. And tidying up, actually working out this integral here, it's simply going to be x sine 2x, and the integral of this is minus a half cos 2x, so with that minus it's going to become plus a half cos of 2x, plus another constant, a different constant, which I'm going to call c2. And I've done the second component. I've done that now, and I've done that. Now we're moving on to this one here. So I'll draw a line under it. Okay, and lastly I'm going to integrate cos squared 2x with respect to x. Immediately you should be thinking, I can't integrate cos squared directly, I need to use some form of double angle formula. So the double angle formula, you should know the following. I'm going to write L for learn. This should be learn. You should know that cos of 2x is 2 cos squared x subtract 1. And do notice this angle here is double this angle here. Now we don't want cos squared of x, we want cos squared of 2x. So we have to use the formula cos of 4x is 2 cos squared of 2x minus 1. Now making cos squared 2x the subject, cos squared 2x is going to simply be a half cos 4x plus 1. Okay, so instead of integrating cos squared 2x, I'll substitute a half cos 4x plus 1 and integrate that instead, because I can integrate cos 4x easily and then integrate 1 easily. So this is going to be, I'm going to take the half outside the integral. That's going to be half the integral of cos 4x plus 1, all with respect to x. And this is a nice simple integral. Keep the half there. Integrating this, I'm going to get a quarter sine of 4x plus x, and I'm going to get a constant, sorry, that should have been a half there, and I'm going to get a constant of integration, which I'm going to call C3. And I'm going to put a line under it. And they are all the parts of this integral worked out. So therefore, combining the whole lot, the integral is therefore a third x cubed. Okay, I'm going to add I'm going to worry about the constant at the end. So it's a third x cubed plus x sine 2x plus a half cos 2x. And then I'm going to times this out. It's going to be plus an eighth sine of 2x plus a half of x. And then finally, what I can do is this constant, I've got a constant of integration here, one here and one here. I can add them all together and I just get another constant. So I'm going to say plus k, and there is my final answer. So although this felt like it could be pretty complicated, if you broke it down into the three individual components, it wasn't too bad. Part of this question asks you to find the volume of the area under this curve as it's rotated around the x-axis. Now you should remember that the volume is given by this formula, pi, the integral between, in this case, between 0 and pi by 2 of our function y squared with respect to x. So the volume here is going to be the integral between 0 and pi by 2 of x plus cos 2x all squared with respect to x. Now, looking at this here, we have already worked this out, the indefinite integral of this in the previous question. Let's take a look. We've worked out that integral as this massive thing here. So all we've got to do is actually, if I just take this at the bottom here, if I paste it along the top here, this integral we said was equal to the following. We don't need a plus c, let's remember. This integral here was equal to that. So all we've got to do is evaluate this at pi by 2 and at 0 and subtract them away from each other, and we've got our answer. So it's going to involve a little bit of work here. And also, sorry, don't forget, this volume was multiplied by pi. There should be a pi out the front. There's another pi out the front here. So keep our pi there. If I put pi by 2 in here, I would get pi cubed over 8, and times by that 3, I would get pi cubed over 24. Putting in pi by 2 here, I would get sine of just a pi, and sine of pi is 0, so this doesn't count. If I put pi by 2 in here, I would get cos of pi, which is minus 1, so this would be minus a half. If I put in pi by 4 here, I'd get sine of 2 pi, and sine of 2 pi is 0, so I get nothing. If I put pi by 2 in here, I get plus pi over 4. That's all in when I put in pi by 2. I'm going to subtract the answer when I put 0 in. If I put 0 here, I get nothing. Put 0 here, I get nothing. Put 0 here, I get a half, because cos of 0 is 1, and a half times 1 is a half. Put 0 here, get nothing. Put 0 here, get nothing. So there is our answer. Tidying up, keeping the pi out at the front for now, I'm going to get that minus a half is going to be, another half is going to be subtracted, so I'm going to get pi cubed over 24. I'm going to have plus pi over 4. That minus a half minus another half is minus 1. And hence, the answer to our question here is going to be pi multiplied by pi cubed over 24 plus pi over 4 minus 1. And that's the answer to this 4-mark question. I hope you found the following useful in your revision for Core 4, and in particular for your revision of the calculus of trigonometric functions. Thank you for listening and watching.